Hi, welcome back. In this video, we are going to design and implementation of a P&O based MPPT algorithm for Cuk Converter based battery charging system. So we will understand how MPPT exerts maximum power from a renewable energy source such as PV panel and how Cuk Converter helps regulate the charging voltage and current. So why MPPT is needed? We already discussed about how MPPT algorithm works based on P&O algorithm. I will attach the link in this video. You can refer how the MPPT algorithm will work and also how to design a Cuk converter. It is also designed in previous video. You can refer both the links in previous. So based on the previous one, today we are going to implement a P&O based MPPT algorithm for Cuk converter with a battery charging system. So in order to understand that, I chose PV array panel 1 kilowatt. So you can I choose at the 1 kilowatt solar panel. So you can refer here the maximum power of the solar panel. I chose the maximum current is nearly equal to 16.62. That is minimum multiplier of 60.2 and 16.62. We will get the maximum power 1000.52. So irradiation of 1000, we will get maximum power is equal to 1000, and also irradiance level 800, we will get maximum power is equal to nearly 807.439, as well as for irradiation level 600, we will get the maximum power is extracted from the PV panel is equal to 609. So around all the maximum power point, it will be appear nearly 60.2, 60.68 and 60.95 volt. So therefore this is the maximum extracting power from this voltage point, and also similarly the maximum current extracted for the difference irradiation level, it will be nearly equal to 16. The next one is nearly it is equal to 13.6 and the next one is nearly equal to 10.1985. So therefore we understand that the maximum power for the single panel is equal to 250 watts. The open circuit voltage is 37.3 and also the short circuit is equal to 8.78. The voltage at maximum power point of the single panel is nearly equal to 30.1. I hope you understand. So we give the irradiance level of 1800, 600. Then, so first I will give a constant temperature, constant irradiance to this PV panel. So I choose 1000, and it's a constant irradiance level. So for 1000 irradiance level, we will get a maximum power is equal to 1 kilowatts. So this is the Cuk converter. The PV panel positive negative end is connected to the Cuk converter. So we already designed how to design a Cuk converter, and previously we discussed about how to simulate the Cuk converter L1, L2, then C1 as well as C2. So therefore two inductance and also two capacitance, and as well as next one is IGBT and also a diode. Then after that a battery is connected with the Cuk converter. So I already told that the negative end of battery will be connected to the positive end of Cuk converter, and also the negative end of the Cuk converter will be connected to the positive end of the battery, because in a Cuk converter the output voltage will be reverse. So that what we connected reverse to the battery. Okay, then this one is a P&O algorithm. So we already discussed how it is working. So here the function of, we take the function of voltage and also current from the PV panel, from the solar panel, VPV, IPV. It is given to the input of the P&O algorithm. So the output convergence will be gate pulses. So this is the input of VP and also IPV. So there are the two inputs, V and also I. Then we will get the convergence value. Final output is equal to D. That D will be connected to the gate pulses G. So this is the repeating sequence. So we generate the D as well as a repeating sequence. Then after that we will generate the gate pulses. This is the design of Cuk converter. So we choose the power maximum is equal to 1 kilowatts. Then the input is equal to 80. I choose the switching frequency is 10 kilohertz and the output voltage is 48. And also we designed the L1, L2, C1, C2. This is what we already discussed about in how to design a Cuk converter in previous videos. Okay, and then we get the C1, C2. I call all the values through call functions. So we are getting L1, C1, L2, C2. Okay. So first of all, why MPPT is needed? Because the PV power depends upon the solar irradiance and also temperature. So without MPPT, the PV panel really operates as at its maximum power points. The MPPT adjusts the duty cycle of the converter to ensure the maximum power transfer to the battery. Okay, then next one is a why we need a Cuk converter? Because the Cuk converter can both step up and step down the voltage suitable for the battery level operation. When you are going to renewable energy application, Cuk converter is very realizable for the solar applications. It provides a continuous input and output current and it also reduces the ripple and increase the battery life. Has battery efficiency compared to the buck boost converter, the Cuk converter based operations will be give the more battery. So now we can simulate the constant irradiance level. We can see here the simulation is running. So here I take the output as of step charge SOC, then battery current and also battery voltage. So this one is a PV power, that is be voltage and also current multiple the we will get maximum power. So we can see that the maximum power is extracted from the PV panel is nearly equal to 1 kilowatts. As well as you look at here the battery current. The battery current is indicates it is nearly equal to negative. This negative is indicates that the battery is charging. Okay, and also the battery, the nominal voltage is equal to 48. So that's what we designed a Cuk converter. The output voltage is 48, and also the rated capacity of this battery is 20, and also initial state of the is equal to 45. You can see here the battery voltage, it is linearly increasing because initially they state that the battery voltage is equal to 48. Now it is reaches nearly 50.61. That is mean by the battery voltage is charging. Okay, I hope you understand that. So this is the characteristics of PV panel. So this is the maximum power extracted from the PV panel, 1 kilowatts. So already told that from the simulation the maximum power is at a irradiance of 1000. We will get nearly 60.2 voltage. So you can see here it is nearly equal to what, 60 voltages. And also the maximum current we will get nearly 16.2. You can see that here 16.5 nearly. So it is a constant irradiance level. Okay, so if we want to check that similarly we want to check that for different irradiance level how it is performing. Okay, so in order to understand that we will give the different irradiance for the PV panel. So I choose the different irradiance level with respect to the time constant. So here at a 0 we will get 1000 irradiation, and also 0.4 800, 0.6 0, 0.8 1000. That is mean by at the 0.0 seconds there will be no irradiance level. So therefore the current will be from the PV panel is equal to 0. Now we can run the simulation. You can see the output of the scope at different irradiance level. When it is 0 second, it is nearly is equal to 1 kilowatt. So you can see here the battery power, it is nearly equal to 1 kilowatt. When the time reaches 0.4, the irradiance level will be 800. So therefore for that irradiance level the battery power will be dropped down to the 800 watts. So see here. So now the irradiance level will change to 800. So therefore we are getting what, 800 watts. Nearly the voltage will be same, but the current will be from the PV panel will be reduced. Then when it is reaches a 0.6, the PV panel current is equal to what? 0, because the irradiance level is equal to what? 0. So it will reach as a 0. So therefore the multiplication of voltage and current we will get what? 0. Still the voltage we will get same voltage, because of that the battery is voltage directly parallel to the appear to the instrument. Then after that, when it reaches a 0.8, once again we will get what? 1000 irradiance level. So you can see here it will reach the 1 kilowatts. So in fourth waveform you can see state of charge. When it is a battery is charging, the state of charge will be increased. When there is no charging, the state of charge will be maintained what? Constant at that level. When the battery is discharging, at the time the state of charges will be what? Reduces. So this is a study of battery charging system. So we successfully designed and simulated the P&O based MPPT controller for Cuk converter for battery efficiency. If you found this video is very useful, please like, share and subscribe.